Okay, for this video, I'll be going through Kinematics Tutorial 1. Okay, question 1. Two athletes A and B are running in a 100-meter race. So this is the distance that they'll be running in. Okay, so total distance is 100 meters. At time t equals to 0, a gun is fired to start the race. So the displacement time graph for the two athletes are shown in figure 1 below. So before you start, you should know what is important about the graphs in kinematics. So the first one is displacement distance graph, dt graph. So there's only this thing. The gradient represents velocity. Okay, and also the y-axis is displacement, the x-axis is time. So you can actually read the displacement of the athletes at a certain time. Okay. Part A, describe the motion of athlete B during the first 10 seconds of the race. So when they ask us to describe, you need to give a lot more details. And motion, usually you can either go by velocity or how the displacement change, okay, and sometimes even acceleration, okay, depending on what kind of graph you are given. So let's look at athlete B's motion. So as you can see, there are three highlighted part, right? Because they say for the first 10 seconds, okay? So for the first part, okay, the answer is as such. From 0 to 3 seconds, okay, you notice that the displacement of B is increasing at a constant rate, right? That means the graph is actually a straight line, okay? A straight line. So if it's a straight line, then it means that the gradient is constant. And in a dt graph, the gradient represents velocity. So we can say that the displacement of B is increasing at a constant rate for the displacement, or B is moving with constant velocity. Okay, then you must be observant to see that at the 3rd second to the 5th second, the line becomes a curve, right? Becomes a curve. So from 3 seconds to 5 seconds, the displacement of B is increasing at an increasing rate. That means it's from gentle to steep, right? So displacement of B is increasing, right? But what is more important is how does the slope changes. It actually went from gentle to steep, so the displacement increases at an increasing rate. Or you can say that B is moving with increasing velocity. How can we examine this using gradient? We can say that the gradient is increasing. Okay, and what does the gradient represent? It represents velocity. Therefore, the velocity is increasing. Okay, the velocity is increasing. Then all the way from 5 to 10 seconds, right? If you actually use a ruler, you'll see that it is actually again a straight line. If it's a straight line, it means that the gradient is constant. And what does gradient represent in a dt graph? It represents velocity. So the velocity is constant. Okay, but some better candidates or students will say that B is moving with constant velocity from 5 to 10 seconds, but the velocity is greater than the constant velocity from 0 to 3 seconds. Okay, part B, estimate the maximum gap between the two athletes. That means the maximum distance between them, and state at which time it occurs. So you need to look at the graph. So the maximum gap will occur somewhere at the 4.8 or the 5th second. And then you can actually count the number of squares, and each square, right? Each square actually, okay, each small square actually represents a value of 2. Okay, so you can work it out to be 16 meters. Okay, part C, calculate the average velocity for the first 5 seconds. So this is important, and it is for athlete B. So for athlete B, we look at its displacement, or the distance traveled, since he's traveling in a straight line. So you can actually work out, if this is the 5th seconds, what is the distance that he has traveled. And since average velocity equals to total displacement over total time taken, the answer is 2.4 meter per second. Lastly, part D, calculate the instantaneous velocity of athlete B at 4.4 seconds. okay, at 4.4 seconds. So instantaneous velocity, okay, is actually the velocity at that point in time. So if we look at 4.4 seconds is somewhere here, it is actually not well, in order to find the velocity, you need to find the gradient, right? But you see that the gradient at this blue color part, it is not a constant gradient. It is not a straight line. So you actually have to draw a tangent. You actually have to draw a tangent at 4.4 seconds. And using this tangent, you work out the rise over the run, and it will be equal to the gradient at that point. Okay? So the answer says that it varies based on your own tangent line. Okay, so this is when the line is not a straight line, it is a curve, then you need to be able to draw a tangent. Okay, so that's for question 1. Okay, question 2, displacement time graph. So again, take note, is displacement time, so dt gradient represents velocity. Okay, so calculate the total distance traveled. We notice that from 0 to the 4th second, the displacement is always at 5. That means it is actually stationary. But how do we prove that it's stationary? Remember, the gradient over here is actually 0. From 0 all the way to 4 seconds, the gradient is 0. And what does gradient represent? Velocity. So the velocity is 0 meter per second. Means it is not moving. So when does it start to move? Okay, so it is from here. It is also moving and also moving, right? Okay, so how do we calculate the total distance traveled? The total distance traveled, it is from the 4th second to the 8th second, he actually increased his distance by 15, right? So this part is 15, okay? Then over here, 20 all the way to 0 displacement, it is 20. And for the total distance, we need to count in 11, so it is another 10. But because distance, there is no direction, right? Whatever he has traveled. So it is, you actually add them up together, is 45 meters. Okay? So what does it mean? If let's say this is the starting point, at 0 meters starting point, he actually started off at the 5 meter mark. Okay, then he moved 15 meters to the right. If let's say positive is to the right, okay, he actually moved 15 meters, and then he actually go back the other way, right? Because it's negative gradient, negative velocity, means he is going back the other way. So how much distance did he cover? 20 meters. Okay, but he did not stop there at 10 seconds. He continued to move in the negative direction for another 10 meters. But the total distance that he traveled is actually 10 plus 20 plus 15. So that makes it 45. Okay. Part B, hence or otherwise determine the average speed. Now average speed, the formula total distance over total time. You take the total distance divided by the total time. Okay, so you get 4.1 meter per second. Remember to leave it in 2 or 3 SF, no fractions. Now calculate the change in displacement of the motorcyclist from his or her initial displacement. Now the change in displacement, remember he was starting at positive 5, but now the change in displacement is actually a negative 15 meters, right? So from this sketch, you can see that the displacement, change in displacement is negative 15. Okay, part D is one of the more difficult questions. Sketch the velocity time graph. Okay, that means we need velocity information and time information. So we start off with labeling the graph, velocity and time. So how do we link displacement time, okay, to a velocity time graph, Remember for dt graph, the gradient represents velocity. Okay, so if we are able to get all the information from our dt graph, we can map it then to our velocity time graph. Okay, so let me clean this up. Okay, so we can break it out into a few sections from 0 to 4, 4 to 8, 8 to 10, and 10 to 11. Okay, so for section 1, we see that the gradient is 0, right? The gradient is 0. Section 1, gradient is 0, which means to say velocity is 0. Okay, velocity is 0. From 4 to 8 seconds, we can actually calculate the gradient. Okay, it will be 20 minus 5 over 4. So it will be 15 over 4. So it is, I think, 3.75. Okay. And we note that the gradient is actually positive. Remember, gradient, this is positive, this is 0, and this is negative. Okay. Then the next section, section 3, is from 8 to 10 seconds. Okay, we notice that the gradient is actually negative. So it is, if I do my, so it is minus 20 over 2, so it's negative 10. Okay, and lastly, section 4. Oh, they only want us for the first, to do it for the first 10 seconds, yeah? Okay, so I don't need section 4. Okay, I don't need this part. So I just need these 3 sections. Section 1, 2, and 3. Okay, so by calculating the gradient, which means we can find the velocity, we see that the velocity is 0 for part 1. That is why over here, I map my velocity to be 0. Okay, and it is a constant value of 0, right? So from 0 to 4, it is 0. Next, from 4 to 8, we have a positive and constant value of 3.75. So that's why it looks like this. And lastly, in section 3, 8 to 10 seconds, the gradient is negative 10. That means the velocity is negative 10 meter per second. Okay, so we map it to this and we are done, right? Okay, for question 3, a car engine is leaking oil as it travels. Drop of oil land on the road at a rate of 24 drops every minute. So in 1 minute, we have 24 drops. Okay. Figure 3 shows a pattern of the oil drops left by the car on the road. So the direction of travel is going from left to right, and this is a speed limit sign. Describe the motion of the car before and after the sign. Now, before the sign, the car was traveling at a constant velocity. Why do we say that it's a constant velocity? Because the gaps made by, the gaps in between the oil drops are a constant value, right? You can actually use your ruler to measure. They should be at a constant value. Okay, so if it's at a constant value, that means the car was traveling with a constant velocity. After the sign, the car accelerated to a higher velocity, right? The gaps is significantly larger than before, right? And that can only happen when the car is traveling at a higher velocity. Okay, part B, calculate the average speed of the car after the sign. So where are we focusing on? After the sign, which is here. Okay, after the sign. And we have 300 meters from this oil drop to the last oil drop. Okay, so over here, I will need you all to count the gaps. Okay, because starting from this oil drop to the end of this oil drop, we have 1 gap, 2 gaps, 3 gaps, and 4 gaps. Okay, and each gap is okay, never mind. Okay, so time taken for these 4 drops, because if we don't count in the first one, it makes the first drop, second, third, and then fourth, right? And remember, 1 minute the car will leave 24 drops. So time taken for the 4 drops will then be 4 over 24 multiplied by 60 seconds, okay, which is 1 minute. So we have answer of 10 seconds. Now, what is the total distance traveled? 300 divided by 10. So we have 30 meter per second or 108 km per hour. Okay, you don't have to leave your answer in km per hour, but you can just leave in 30 meter per second. But please do know how to convert from meter per second to km per hour.